Let's begin. Today is June 19th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 6, 8, 18, 21, and 22. And they use the green verification cards. The code above is your way to get more details on today's puzzle by going to turingmachine.info and searching using the code above. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at that first digit, the triangle digit, and compares that to the number 3. So should the triangle value be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at the middle digit, the square digit, and will let us know whether that value is an even or an odd. Criteria card C looks at our 3-digit code solution and will let us know how many of those should be 1. Should there be no ones, a single one, maybe 2, perhaps all 3 are 1s. Criteria card D again looks at our 3 digits in our solution, triangle, square, and circle, adds them together, and will let us know whether the sum is an even quantity or an odd quantity. Criteria card E again looks at our 3-digit solution and will let us know a little bit about how it's structured in the sense that could there be a pair, a repeating digit, as in the example 131, or alternatively it has no pair, but there are a couple of possible scenarios. They could all be different digits, as in the example 134, or it could be the same digit repeated 3 times, as in the example 222. And finally, criteria card F again does look at our 3-digit solution and will let us know something about how the digits are ordered. Are the numbers ordered in an ascending fashion, meaning that they're increasing, like the example 135? Are they descending, decreasing, as in the example 421? Or do they have no order, as in the example 231? So if you notice the 231, one way to define that it has no order, notice that it goes from 2 to 3, so it increases, but then it goes down, it drops down from 3 to 1. That's one way to define the fact that the 3-digit code has no order. And remember, we're looking for this one unique code, 3-digit solution, that abides by all of the criteria cards that we described. And we're going to begin with our proposal of 314. So the first thing I want to test is I want to find out whether that middle digit is an even or an odd. So I'm going to test criteria card B. Okay, so the Turing Machine responds that it does not agree with my proposal. So if you notice in my proposal 314, I chose an odd 1. So since the Turing Machine does not agree with that, that means that that middle digit, the square digit, must be even. So that's what I'm going to write in my notes in section B. Square is an even digit. And since it is even, that means I can cross out all of the odds for square. Okay. So we also have criteria card D that will let us know, if the sum is even or odd. Let's go ahead and test criteria card D. Okay, so the Turing Machine approves of my proposal. Since criteria card D adds the digits, let's go ahead and add what I have. So I have 314. So 3 plus 1 is 4. 4 plus 4 is 8. That sum is even. The Turing Machine agrees with that. So that's what I'm going to write in my notes in section D. That triangle plus square plus circle should be an even quantity. Alright, so since we already know we have an even digit in square, two possibilities are possible. That would mean that triangle and circle have to be the same type of number, meaning they either both have to be even or they both have to be odd. And that's because whenever you add, two odds or two evens, that sum is even. But of course, that third digit has to be an even so that the total sum remains even. So that's a good opportunity to test criteria card E to see if we have a pair of digits or just the same type. So let's go ahead and test criteria card E. Okay, so the Turing Machine approves of my proposal. Notice that I do have 314. That is a no pair. So we have no pair in our solution. So that's what I'm going to write for criteria card E, that there's no pair. So that didn't really clarify whether we have two odds or two evens. That's still an outstanding question since they are unique. So we'll just have to come up with a good second proposal. And that's where we're at now. We already completed our 3 tests for this round. We're now going into the phase where we're going to kind of discuss what we didn't test and how to construct a good second round proposal. Okay, so notice that we did not test criteria card A, where we're comparing the first digit, the triangle digit, to the number 3. We also did not test whether we have a 1 or not, and we didn't test the ordering. So as far as criteria card C and the number of ones, obviously there can't be 3 ones because we do have an even, and we can't even have 2 ones because we know that there's no pair. So and of course it can't be the triple digit, since, well, let's see, could it be a triple digit? They could all be even. That's a possibility. Is there anything else that could? Well, I think it can't be a triple digit, because if we knew it was a triple digit, then criteria card F would be irrelevant. When you have the same digit repeated 3 times, that would mean that there's no order. And so this card would become superfluous or irrelevant. So I don't think it's going to be a triple number or a digit repeated 3 times. So we're looking for, again, either 2 odds in triangle and circle, or 2 evens, and then of course that middle digit is even. So going back to criteria card C, either the 1 is there or not. And that's interesting. Yeah, if it's not, well, it still means it could, the odds could be 3 and 5. Oh, let's see. Okay, I think we have narrowed it down. Since they are all unique, right? There's no repeating digits, there's no pair. They have to be odd. Otherwise, when you only have 2 and 4 as evens, one of them would have to be paired up. Okay, so fantastic. So we've already kind of concluded that that triangle and circle have to be odd. So triangle and circle are odd. And again, the reason for that is that if they were both even, either 2 or 4 would be paired up. So that means I can cross out all of my evens for triangle and circle. Okay, so that's great going into this phase where we're trying to narrow it down. Okay, so we definitely know there's an odd in triangle and circle, which means that if there is a 1, fantastic. We've narrowed at least one of them down. But if not, then we know the odds have to be 3 and 5. So that's advantageous. So let's see, what else do we have? Again, we still have criteria card A. So that'll narrow the odd digit in triangle. And so circle, notice other than criteria card D, there's no mention of circle. So circle is going to be forced into that other odd. So it could be that maybe there is no 1, and so the circle is going to be forced into being a 3 or a 5, again assuming there might not be a 1. And we do have triangle being 3, so it could be that it's 3, and then we have an even, and then a 5, again assuming that there is no 1. So we could have something like it's ascending 3, 4, 5, or potentially there is no order 3, 2, 5. Again, I'm going with the assumption that there might not be a 1. So yeah, let's go ahead and test that. I don't think there's too much advantage into considering too many other options. All right, so I'm going to go with 3, 2, 5. And let's see where that leads us. Okay, so but I do want to consider the order of the verification, or sorry, the criteria cards I want to test. I'm trying to see if I can avoid at least one of them. So let's go ahead and test criteria card C to see if there are any 1s. Okay, so the Turing machine approves of the fact that I don't have a 1. So yeah, so there were no 1s to begin with. So let's go ahead and write that down in our notes. There is no 1 digit. And so of course we can cancel out the remaining 1s up above, the 1 for triangle and the 1 for circle. And so yeah, so the odds have to be some combination of 3 and 5. So let's see. So we know we can't have any duplicates. So I think there should be 4 total possibilities. Let me go ahead and list them out kind of quickly here. So we know we can start off with 3, and it would have to be 3, 2, 5. Remember, no repeats. Or it could be 3, 4, 5. Otherwise, it would have to start with a 5, and it would be 5, 2, 3. Or 5, 4, 3. Okay, so we notice that 3, 4, 5 and 5, 4, 3, one's ascending, one's descending, and 3, 2, 5 and 5, 2, 3 have no order. And of course we still are testing, yeah, for criteria card A, it's whether it's 3 or 5. So I did choose a 3. If I narrow that down, would that help? Well, if it's 3, we have 1 no order and 1 ascending. And if it's the 5, we have 1 no order and 1 descending. So it looks like we may have to test the remaining 2. Is there any way I could deduce either criteria card A or F? Do we know, can we be sure that there's no order or either ascending or descending? I don't, well, let's see. Well, no. Yeah, let's just go ahead and test it. So let's do criteria card A first. Okay, so yes, so I did pick a 3 for my triangle value, so that's true. The Turing Machine approves of that. So let me write that down, that triangle does equal 3. Oops. There we go. Triangle equals 3. And so let me go ahead and cross out the 5 above. And of course, since it is 3, it can't be these last 2 potential solutions. Okay. And so yeah, so we're dealing with either something that has no order or is increasing. And I don't think I can conclude or deduce one way or the other. So let me go ahead and test criteria card F. Okay, so yeah, so it's 325. So let me go ahead. So it wasn't ascending. And of course then that means it's not a 4 for square. Alright, so that's our solution, 325. Oops, let me cross out the 3 here. So 325. And just really quickly, let's just verify before we go to turingmachine.info. Yes, the first digit is 3. The middle digit is even. There is no 1. The sum is even, yeah. The sum equals to 10. There are no pairs, and yeah, the first and last are odd, and it has no order. So yeah, so technically, I guess I forgot to mention that my proposal 325 has no order, and when I test it, I should have written down that there's no order. Okay, so yeah, everything looks good. So let's go to turingmachine.info and verify. So 325. Fantastic. And I believe we did test all 6. And you know, whenever you test the same number of queries as there are criteria cards, typically you'll at best tie, or at least tie with the Turing Machine, but potentially you could beat it by a couple of queries. Alright, so we noticed that the only thing that failed was B, and we did BDE first. So B failed, D and E checked out, and when we constructed our proposed second round proposal, we got it just right. All right. As suspected, yeah, we tied with the Turing Machine. Yeah, it was one of those where, you know, we both got it in 6 questions in 2 rounds. But still, you know, what I do like about the Turing Machine puzzle is that sometimes some combination of these criteria cards produce some kind of remarkable solutions, and that's what I really enjoy about Turing Machine. I hope so for you as well. Well, if you notice anything in the video that you'd like to share, please do add it to the comments. If you did like it, give it a thumbs up, and if you don't want to miss any future videos, hit subscribe to be notified. Well, this was a great one. Until next time, have a great one.